All right, it's recording. Here we go. So they already tell you. They tell you it's a rectangular hyperbola. And usually in your textbook, they always give you the template. Your skill is eventually you don't need a template. So exercise 3K or the one on your sack, I didn't give you a template, but I gave you the answer. I said the answer for, I think it was a Japanese skier. I said, this is the Japanese skier's equation. I already gave you the answer. I just wanted you to show me how did I get that answer, right? It's the same thing here. They're giving you the answer. What they want you to do is say, well, how do I get that answer? Okay, how do I get whatever the final answer is? So here we go. This is my answer. Passes through the point, -2.6, find the value of A. Now, before you even answer the question, I want you to picture what's happening. What's something about the equation that we definitely know? So this here, I don't know what A is, but I know it's a rectangular hyperbole and there's a +8. What do I know about the +8? What does that tell me? It goes up. And a rectangular hyperbole normally looks like this. And it has two key properties. A horizontal asymptote and a vertical asymptote. You should do that in dotted lines, right? So if you shift this graph up, like Luke said, up by 8, your asymptote, your horizontal one, should now be at y equals 8. Because it used to be at y equals 0, right? And then you had that shape, it looks like this. But now it's shifted up. Then you still have that shape, except that's what it looks like. Whereas the vertical asymptote stays there because you only moved up and down. You didn't move left and right. And from the template, it doesn't look like it's telling me that I'm moving left or right. Okay, so that's one of the first skills that you should be able to identify that +8, this is what it roughly looks like. What I don't know is this the correct shape for A? Because A could be negative. If A is negative, then the shape will look like this now. See what I mean? Now let's find A. How do you find A? Well, you need a point somewhere. They gave you a point. They said a -2.6. So -2, and at 6, well, 6 should be below 8. So 6 should be somewhere here. So it's very likely it's going to be this shape. Because 8 is here, that's the boundary. And -2.6 has to be here. It couldn't have been this graph. This graph should have had at -2, it should have been a much bigger number than 8. See what I'm doing with my logic? Yeah, that ability to analyze the function based on an equation is what you're trying to take out from 4F. Same thing with 3K. The 3K is not about you memorizing the equations, it's about you analyzing it. Yeah? So here I can already predict that likely it's a positive number. Let's test it. Here we go. So you got y equals a on x plus 8. You know that it passes through the point -2.6. What that implies is that when x is -2, y is 6. So my equation, that x, when it's -2, the y value should be 6, according to that point. So we sub it in. We say, all right, well, this is now 6. A divided by -2 plus 8. Inverse operations, get rid of the numbers, Sam Dobb. So it's not a BODMAS, you do go backwards, Sam Dobb. So get rid of +8, -8 on both sides. That gives you -2 is equal to A on -2. How do I get rid of that divide by -2? I want A by itself. What do you do? Times by? -2. Yeah, times both sides by -2. And that gives you A is equal to 4, which is what I predicted. So even though I didn't know what A was before, I knew one thing just from looking at the graph. I knew it had to be a positive number. And that was just my analysis. Yeah, my analysis of the fact that 8 goes up by 8, asymptote is at 8. Then they told me it passes at -2.6. It was impossible for that point to be up here. So it couldn't have been a negative graph. It had to be a positive graph. That's the ability that you want to be able to take. That when you look at an equation, that's what you're visualizing. Because methods is all about analysis. Yeah, so you're learning all types of functions. This whole year, you're going to learn not just quadratics, you're learning cubics, quartics, rectangular hyperboles, truncus, square root, circles. You're going to learn sine graphs, cos graph, tan graph, exponentials, and logs. Those are the most basic graphs that you need to know. And they all follow the same thing, up, down, left, right, reflected. We're going to talk about transformations later on, but that's what you're doing. You're learning all these different graphs so that you can analyze their properties and then do what I just did there. Does that make sense? Yeah? All right, so next one. So it just means your equation is y equals 4 on x plus 8. So in your SAC, this is pretty much what I did. In your SAC, I gave you the equation, which was a quadratic one, and I just wanted you to show me how I got there. This is all you have to do. So you had to come up, well, how did I come up with this point? If I remember correctly, the Japanese skier, I gave you a turning point. I told you the highest point he reaches after a certain point. So I gave you a turning point. All you had to do was just write out turning point form, sub in a coordinate, which I gave to you at the starting point when you first jumped, wherever the y-axis intercept was, sub it in, solve for whatever the number was, and then you would have got the equation. Okay, so that's what that exercise was. So that question was 3K. Yeah? All right, let's go this one. Same idea. This one, a graph which has the rule. So they gave you a template. Here's your template. We know it's a square root function then. Square root function passes through the point 4, 2 and 7, 4. So we had to quickly visualize this. Let's do a bit of visual. Square root function. X minus h. Usually, what does that tell me? What does the x minus h usually tell me? Hands up if you know. What happens? So hypothetically, if this was -1, what does that tell me? Move to the right by 1. So right now, I just don't know what h is. H could be a negative, so it ends up being +1. But all I know is this should tell you left or right. But it doesn't tell me up or down. So what I'm picturing right now is I could have that square root graph. Could be like this, could be like that, who knows? It's just moving left and right, yeah? What I do know is that it does pass through 4, 2. So if you have to visualize where 4, 2 is, 4 is here, 2 is about there, so it's likely that this can't be correct. It's probably this direction, right? So it might be here, that's 4, 2. What's another point they gave us? 7, 4. So 7, 4, 7's over here, 4's double that, so it's somewhere here. So it's very likely it's heading this direction. Even though I don't know what A is, remember A could make it go upside down, but clearly at the moment it looks like it's increasing. So what I'm almost certain, just from looking at this graph that I'm drawing, is I'm picturing it has to be A is likely positive. Because if it was negative, if A was a negative number, that graph would have been like this. And then it doesn't make sense that how is it going to pass two different points that's increasing? So very likely, A is going to be a positive number, even though I don't know what it is yet. Just by analysis, I can probably say, either move right or left, doesn't matter, but the point is, it's going up. Okay, it's positive. So let's test it. Let's see if it's true. Here we go. Passes through the point 4, 2 and 7, 4. You've got two unknowns, and they gave you 2 points. Very likely, you're going to be doing simultaneous equations. Yeah, so here we go. Sub 4, 2 in. So on x is 4, y is 2. So here we go. We've got 2 is equal to a times the square root of 2 minus h. Okay, I'm just substituting them in. 4, 2. That's my equation 1. Equation 2, let's sub in the next one. Sub 7, 4. I would now get 4 is equal to a times the square root of 7 minus h. Yep. Oh, yeah. Thank you. 4. All right, so now I've got my 2 equations. Now it's up to you on how strong your algebra is to solve this. Has anyone got an idea? How do I simultaneous these two? Because it's not like your linear equations where you do, ax plus by and then you subtract or whatever is elimination method or substitution method. What do you do when you have a square root now? Anyone have a clue what they might do? Hands up if you have an idea. Oh, no one. All right, let's try this. So, when you get to these kind of problems, this is where the problem solving comes in, and there's a lot of ways that you can do this. Square root is the problem. You can square both sides if you like. That could be an option to do. But squaring both sides only gets rid of the square roots, but you end up with a squared and a squared here. One of my tips for you is that you can do a division. Okay, it doesn't always have to be add and subtract. You can do division as well, right? So what I can say here is I can say, why don't I divide, let's say I divide this 4 by 2, because that's a 2 there, yeah? So I say, take equation 2 divided by equation 1, so 4 divided by 2, and then that means whatever you do to the left, you do to the right. Now if I divide this by 2, that's hard. We can't do that. But since 2 is also equal to this, I can rewrite that 2 and say, well, I'm dividing by a square root 4 minus h, right? That's why elimination method works, because you're pretty much doing both sides. So divide 2, and 2 equals to this, so I'm just writing that as 2 as well. That's equivalent to 2. What's nice? Your next line. 4 divided by 2, we know is 2. Your question is, how do you do a square root of 7 minus h divided by a square root of 4 minus h? Does anyone see something special? Why did I divide? There's a reason why I chose to divide. I can get them all in one equation, but there's something even better than that. Yeah. This part here, you can't do surd divided by surd. Or actually, you can combine them together. But the a divided by a, see at the front of that just means times. But we know that if I separated the two, a divided by a cancels out to be 1. Yeah? And then here, I've now got this fraction. So I'll just take this graph away so I've got a bit more space. Let's do it again. So I've got 2 is equal to, the a's cancel out, and you got root of 7 minus h all over root of 4 minus h. So the a's cancelled out, and I used the elimination method there. Okay, the aim is to remove one of the parameters. Now I only got h, you got one equation, one parameter, or one variable. You can solve now. Okay, one parameter actually. So, how do I solve this? What are you going to do? Anyone have clues now? Is this a bit easier to do now? Yeah, there's 2 ways to do this. If you don't like the fraction, and I've always taught you, if you don't like fractions, get rid of it. That's divided by root of 4 minus h times both sides. Nothing wrong. You can do that, right? For me, what I would have done is I don't like surds. I hate square roots. I get rid of it as soon as I see it. One of the rules that we know is that if you took root 4 divided by root 5, that's the same thing as writing square root of 4 and 5. Yeah, that's one of your surd laws. So if you multiply it, say root 2 times root 5, that's the same thing as saying root 10. Then the same thing with division, you can combine that. So if I combine that, that gives you 7 minus h on 4 minus h, 2. Why did I combine it? Because now I can get rid of the square root. What's the opposite of square root? Squaring. So here I'd say square the left, square the right. Squaring the left gives me 4. Squaring the right, square and square roots are opposites, so they cancel out. And then now I have my fraction, which goes back to what Anthony had suggested before. You can now do that, but at least you don't have surds now. That's much easier to do. Yeah? So from here, this is when I would use what Anthony just said before. If you don't like fractions, get rid of it. That's divide by 4 minus h times both sides by 4 minus h. These two cancel out to be 1. You get 7 minus h is equal to 4 times 4, and then 4 times negative h, which is 16 minus 4h. And then from here, everyone should be able to do. Yeah? So from here, you're back to linear equations that my year 8s are practicing in term 3. 2 unknowns on both sides, collect them together. So you can add 4h on both sides if you want. Add 4h. Add 4h. And the next line should give you 16 equals 7. And what's that? 4h minus h is 3. These two cancel out. And minus 7 on both sides. You get 9 is equal to 3h, and therefore h must be equal to 3. How's that feel so far? Yeah? So I know this step here, that's not easy. This is about you seeing all the varieties of different ways to solve a problem. So I'm telling you, you don't always have to do plus minus for simultaneous equations. You can do divide as well. You'll find that you use division and multiplication for exponential and logs. So when you get to exponential and logs, you'll do more of this as well. So you build up on those skills. Okay? And then surds, just knowing how to work with your surds there and how you get rid of fractions. Just some of those little tricks will help you throughout the year. So the next 6 months, that's what you're trying to build. You need to build that sort of arsenal of algebra skills to be able to solve any problem I give you. Cool? All right, so you got h equals 3. We're not done. We haven't found a yet. We know h is 3, so that means it moves to the left. Oh, sorry, to the right by 3. And now to find a, how do I find a? What are you going to do? How do you find a? You got h is equal to 3, so to find a? Yeah, which one would you do? You got equation 1, equation 2. Which one would you sub in? Yeah. Why would I do 1? Because I can see 4 take away 3. It's going to give me 1, and square root of 1 is 1. That's easier to do rather than this one. True? So do a bit of problem solving before you just sub in things. Have a think. Which one's going to make your life easier? So for me, I would have done sub h equals to 3 into equation 1. So that means that you get 2 is equal to, so 2 is equal to a square root of 4 take away 3. Root of 1 is just 1. So conveniently, a equals 2, which is exactly what I said at the start. Even though I didn't know the graph, I didn't know what a was and h was, I was able to predict that it was going to be a positive value. And I was correct. And that's how you proofread. So that's why the top students at year 12, they have that analysis. So when they do their calculations, if they get this as a negative, they're like, wait, something's off. Then they can go back and check. That's why layout matters. That's why analysis matters. Because if I got a negative answer here, I know I've gone wrong somewhere. But if you didn't have that analysis and you weren't sure that A was definitely positive, you might have accepted that that could have been a negative. Yeah, so that ability, that's why the top kids often make less mistakes. The layout is clear. They can always backtrack and figure out where they've gone wrong. So layout is key. Yeah? All right. Maybe I'll leave the next one for you to try. That's a circle, and I'll write up the solutions for that one. Let's have a look at, turn over to the next page, and we'll finish off there. You got a graph. This is where you're using your properties. Look at that graph there. I've got a color code there for you, or colored version up on screen. What type of graph is this? Truncus. So starting off, you should be thinking y equals 2, 1 on x squared. That's what you should be thinking around, right? What I haven't given you is a template. This is very similar to the SAC question. So I could have gave you something like this and then said, figure it out, right? Oh, actually, I think I haven't given you a value too, actually. Oh, that's not enough for you to solve, is it? No, that's not enough for you to solve. I'm missing too much information. Let's make it up. We're going to make it up on the side. Let's say, what would make this work? Has to be... Oh, I didn't put in the values here. He pause that video for a bit. So I was missing those two. Now using those two asymptotes, you should be able to figure out what the equation template should be. So let's have a think. In order for you to have a horizontal asymptote of y equals -2, what must happen? What must happen? So think about the horizontal asymptote. Usually it's up here. Now it's here. What do you want to do? Good. You need that up, down. You need it technically. Usually it starts at 0. It needs to be now down at -2. So it needs to go down by 2, right? So we need it to be -2. Wait, did I do that wrong? Oh, wait. My numbers are all wrong. Should be -3. Sorry, my bad. It should be -3. -3. So we got 1 on x squared -3. Then, how do you make sure that you have a vertical asymptote at x equals 1? What must happen for you to have an x equal 1? Very good. Remember, what you're doing to the x is what affects it moving left or right. So your equation, if you want it to move to the right by 1, we know it needs to be x -1 squared. That moves it to the right by 1. And then this -3 will ensure that you also shift the graph down by 1. What's the problem? We don't know what the dilation is. That's why they gave you a coordinate there. Okay, so that means there has to be a times A somewhere. Okay, so that's one of the things that you have to practice doing, especially in that SAC, that exercise 3K. If you did 3K, there's a couple of times you have to find the dilation. So here, how do I find the dilation, which is what I don't know? Sub in the point. So they gave you 0, -1. So let's put it all together. Y is -1. A you don't know, times x, which is currently 0, minus 1 squared, minus 3. Let's solve for this. A times 0 minus 1 is -1. -1 squared is 1, but the 1 divided by 1 is 1. So you got 1 here, and then take away 3. A times 1 is A. You got A take away 3 equals -1. So that must mean A is equal to 2. So for this equation to work, where you have an asymptote at y equals -3 and x equals 1, the equation must be 2 times 1 on x minus 1 squared minus 3. Usually we write it together. We do 2, write 2 as a fraction, and it becomes 2 over x minus 1 squared minus 3. Okay. And that finishes that exercise. So if you're doing exercise 4F, that's what you're practicing. So you need to know the transformations. You need to be able to read left, right, up, down. And you need to be able to decide what function do you have. Is it a hyperbole, truncus, square root, or a circle? Okay? I'm going to stop the video there. And for those who want to try example 3, have a go at circles. Otherwise, go back and make sure you practice ABD.